welcome Shikma Litmanovitz, Technion, Israel Institute of Technology.
My name is Shikma Litmanovitz, Director of Business Development at T3 Technion Technology Transfer. My prime mission is to continue crossing boundaries and creating bridges between academia and industry. Today I have the pleasure to nominate Tamar Robotics as the science breakthrough of year 2023. What is the unique contribution of Tamar Robotics? Tamar Robotics, founded by Professor Moshe Shoham from the Technion Faculty of Mechanical Engineering, is developing endoscopic robotic systems, primarily neurosurgery. Based on an innovative kinematics, the technology enables highly accurate and safe robotic surgery in highly challenging workspaces, where robotics currently cannot be used.
Breaking the wall to robotic tumor removal in neurosurgery. Noam Hassidov, Tamar Robotics.
Hello, my name is Noam Hassidov, and I'm the CEO of Tamar Robotic. Thank you for having me. This is our brain. What a beautiful machine. It's really amazing. This is what makes us human. But sometimes tumor happen within the brain. And today neurosurgeon can go all over the brain and perform surgery. But the problem is that they have to open a wide space in the skull and generate a corridor harming healthy brain tissue in order to get into the tumor. Once the patient come back home, we have a big question: will he be able to walk? Can he speak to his loved ones? Can he have a normal life? And at Tamar Robotic, this is what we're fighting for the life quality of this patient after the surgery. This is our mission, and this is our wall. You can see on the right side, Intuitive Surgical, the state-of-the-art robotic system to date, with the sales of $5 billion a year, really impressive company. And then you can see on the other side, Tamar Robotic, and you can see the major difference between those two systems. So let's speak a little bit about robotics. In the 90s, Intuitive Surgical decided to go into cardiac and then general surgery or general laparoscopy, and they have chose a kinematic called arm, joint, and arm. And this generates very good way to work and to tie knots and to cut and so on. So, and everybody in the market is doing it today, but it requires big cavity, about 10 centimeters over 5 over 5. This can happen in the thorax, in abdominal, but there's no way you can put such huge and amazing machine into the brain. We're doing it literally in way smaller sizes. Now, in 2014, Intuitive Surgical decided to go into the brain. They have done cadaver study, and they saw and published that the opening and damage they are doing to brain of cadavers is significantly higher than the standard of care today. And although they tried to smaller their system, it couldn't be done. And if there's one thing I want you to remember from the meeting today, is these two approaches. And it would probably be nicer if I was standing on the table in the room with you. But you know, this is the opening size when you're doing standard general surgery in the brain today, about 4 to 5 centimeter opening. And this is the size you need to open the brain in order to put Tamar Robotic into it. Now, there's no question what we and our patient will prefer: an opening this size and a finger like that size. You know, just put it in front of you and see the huge difference in size when you open the skull and you damage the healthy brain tissue once you go into the tumor size. This is our system. This is how it looks like. Robot that can approach the brain from several areas. It can approach from the skull, from the spine, from the nose, you know, from the sinuses, from a lot of areas. The physician sits on a console and holds 2 joysticks. But a lot of people are asking me, so why robotics? So the first thing is tremor. Okay, when you're holding for 5 hours or 6 hours a tool above a patient, you get a tremor, even if you're an expert neurosurgeon, and the robot reduces it totally. You can move your joystick for 5 centimeters, and the tip of the robot will move only 0.5 millimeter, so you can scale it down. And one of the most amazing things that we learned across, you know, we've been consulting with more than 100 neurosurgeons worldwide along the way, and what they really like, that they can let go of the joysticks, the tools stay and hold the brain, They're looking at the MRI and the CT, speaking to their colleagues and continuing back. And something very important today, all of the industry of human robotic for abdominal and thorax surgery is based on CO2 insufflation. You apply pressure, the abdominal expand, and you put your tools inside and robot works. If you're going to put pressurized CO2 into the brain of the patient, you're literally going to kill him immediately. We're the only company to date that is doing it without CO2 insufflation. Let's look how our robot looks like. So you can see the blue is the suction tool. The other one is a curette. We can put any kind of tools that the physician would like. Look at the speed, the agility. We can have our cameras going in and out to zoom in precise location or to zoom out a very wide axis. And both axes can go in and out doing that. To date, Tamar Robotic next milestone is 2 years from now, conducting first in men clinical study, both in Israel and in Europe, probably either Spain or Germany. We are raising around now $5 million from it. $3 million is already committed. And last but not least, amazing team. Myself, been a CEO for 15 years. Yes. I have Dr. Adassi, so are we done?
Yes, I'm sorry.
Thank you. No problem.
Thank you. Yes, that was perfect.
We have an amazing team.
You nearly made it.
Yes.
Wonderful. It's good to finish with the team. Yeah, it's true. We are only there because we have also great teams also like with us, right? So, okay, questions. Who is starting? Yeah, what? Okay, so you have a question mark. This is good. Okay, Gita will be first. Thanks for the microphone in the first row. Gita, you go.
Great presentation. Can you please tell us more about your team?
Yes, great
Very
question.
good one.
Very good question. So we are working with a lot of physicians. One of our founders is Professor Moshe Shoam. He founded the industry of spine robotic 20 years ago, and his company was sold for $1.6 billion. Today, about 10 companies are mimicking his robots. And when 10 companies are mimicking your robots, you probably have done well. And we have experts both in sales. Chris Parentis have worked in intuitive surgical. We have an amazing team of physicians. Oran is using both. He owns part of his hospital, so he knows both Excel and both how to do surgeries. Kristen, really one of a kind. In 2019, and this will be the last one, she envisioned something, said, I want this to happen during surgery. And we said, we can do that. And then after 3 years, we found a solution. So, really amazing team that helps us along the way.
Yeah. Can we have the timer back to 2 minutes? 2 minutes, please. I think I have one question here. No one in the jury. I see you also behind, but he was first, Stefan. Sorry. No, please, no, Stefan, go on.
What would it need to take your innovation to TLR8 from 6? What's needed? And what could be the obstacles on the road?
So I think we're past, once the cadaver study was done, I think we're past the side of R&D. There's a lot of heavy lifting in the engineering side, okay? So, going from a cadaver study side to a system that could be sold, you can ship 10 systems out. It's really a lot of engineering. And by the end of the day, the amount of money that should be invested in Salesforce, as we all know, is significant more than development itself.
Thank you. Tech team, you can add 30 seconds. It's a mistake on my thing. Yes, please. I will take you, and then we will have this in case the jury doesn't come.
It's really inspiring work. So I'm wondering, so with microsurgery, right, especially with brain tumor, it's already very hard to distinguish tumor tissues compared to healthy tissues. So would your technology affect the precision of the medicine? Thank you.
Thank you.
So first of all, absolutely yes. It's a little bit longer to explain here, but generally, The difference between us and standard of care, that the tip of the system that works in the brain is registered in less than a millimeter precision, and thus you can generate a lot of outcome that enable us to know the point of the tumor that physician can do it by hand today.
Okay. Last question then from the last row. Thank you.
With respect to positioning accuracy versus being able to navigate in 3 dimensions, is this system going to be MR compatible, or how do you maintain overall positioning accuracy within the brain?
Okay, so thank you for your question. No, it's not going to be an MR system. Building a tiny robot is challenging enough, and making it MR compatible is literally, I won't say impossible, but really hard. But since you're drilling a small hole into the brain shift is significantly lower, okay? And the second thing, because you don't move the shaft of the robot or the robot base, you can do additional O-arm pictures or CT as you go, and have a registrator that today is spanned about 4 to 3 millimeter in the industry. We think that we can reduce to less than 1 millimeter real registration.
Great. Thank you very much for this. We made it with the 4 minutes. Thanks.